All right, so we're going to take a look at solving systems of linear inequalities, as well as just reviewing what you've previously learned solving systems of equations and the differences between the two. As always, this is the Desmos version, so we're going to go to Desmos. So this is Desmos, graphing, and you're going to put the state that you're in. We are in Georgia for now, so you're going to put Georgia, but you're going to put whatever state that you're in. This is because there are different testing calculators that have some capabilities that are not open to the regular Desmos. All right, so solving systems and equations, and all we're going to do is follow instructions. So it says copy and paste both inequalities into Desmos on separate lines. All right, so looking at example 1, we're going to copy both of these equations into Desmos on separate lines. And once again, the big deal is whether you copy it correctly. So please double check. You're looking to make sure that you've copied it exactly as it says. Okay, and then I'm going to copy the second one on separate lines. X is greater than or equal to -3. Just double check, because this is the big thing. Either you copy the equation wrong or you transfer the lines incorrectly. So that's going to be your biggest problem, obviously, using the calculator. All right, so I copied and pasted both inequalities on separate lines. Click the second colored circle on the left to hide the second inequality and copy to your answer. So second colored circle to hide it so that it doesn't confuse me, so that I can copy this into my answer. Click so let's copy it first. All right, so let's copy. We're copying this line here. And again, remember to copy it. You're going to click on the nice points, and you can see it's horizontally at 0, 1. So I'm going to go X and then Y. X is 0, Y is 1. X is 0, Y is 1. All right, boom. And then it's horizontal like this, right? So I'm just going to do a dashed line. So again, biggest mistake is you copy something different. A dashed line, and where is it shaded? On the bottom. That's the first one. So shaded. Now you need a different color. So either grab a color pencil or a highlighter, or use a pen and a pencil, because we're doing 2 equations. All right, on the other side, it says click the first colored circle. So click the first colored circle on the left to hide the first one, and unclick the second and copy it onto your answer. So now we're on the second one. You're going to change the color. So either you're using a pen and then a pencil, or vice versa. So I'm going to change the color. This one's going up and down. I just need a good point. So let's see if this is going to be a good point. It is. So I'm going to go to X, then Y, 3, then 0. So 3, then 0. So it's right here. And it's a line going up and down. So this is a different color, and I'm going to shade on the right-hand side. So this one goes like this. Okay, boom. So I shaded both. So if I unclick this, let me not get ahead. Note, pay careful attention if the line is dotted or solid. I did. Unclick the first colored circle and pay attention to where the colors overlap, as the coordinate is, as any coordinate in there is your solution. Stay away from dotted lines when picking a coordinate in the overlap and shading. Okay, so we're going to take a look again. I'm just going to hide this. Does it look like the colors overlap? Actually, I don't want to hide it because I want to do this. All right, so if I unclick it, look where it overlaps the pink. All right, where does it overlap the pink? Top left, top right, bottom left, bottom right. Okay, so where does it overlap the pink? All right, you should have said bottom right, and you can see it here a little bit more clearly. You've seen green and red. Here they're boxes, but here they're just lines. So this is the overlap. Anything in here is what these notes are saying is your solution, but stay away from dotted lines. So let's talk about that, since I didn't write it on your notes. Let's give us a question. Is, let me pick a coordinate. Is 5, 1 a solution? So you're going to copy that down. Is 5, 1 a solution? All right, so again, remember we're going to go to 5, 1. So I'll pick a completely different color. All right, we're going to go to 5, 1. So X and then Y, 5, then 1, right here. Is that a solution? Okay, so it looks like there are 2 boxes here, but what's the problem with this line right here? It's what? Dotted. And it says, do what? Stay away from dotted lines. So is that a solution? No, because it is dotted. Okay, dotted does not include. All right, let's do another one. Is, and copy this down, is, let's say, 3, -3 a solution. All right, 3, negative 3, a solution. So we're going to go to 3, negative 3. I'm just going to change the color so you can see it. All right, 3, negative 3 is right here. It's on this line. Is this line dotted? No, so this is a solution, okay, because that line is not dotted. Okay, so again, just stay away from dotted lines. Is it a solution? And really, let me just explain what this means. I'm going to just substitute the values in here, but here's the key. It has to work for both of them. So let's take this one right here, okay? It has to work. These coordinates have to work for both of them. Since I said it's a solution, it has to work. All right, so I'll start with this one. It has x, right? So I go to the x value, 3. Is 3 greater than or equal to 3? Yes, it is. But that's just one equation. I have to check the other one. This one is y, right? So the y value is negative 3. So I'm going to replace y with negative 3. Is negative 3 less than 1? Yes, it is. That's why this is a solution. All right, so let me check the other one. Let me put my equations back. Okay, now I'm going to check this one. So this one's x, so I go to the x one. Where I see x, I put 5. Is 5 greater than or equal to 3? Yes, it is. So I would stop thinking that this is a solution, but remember, you have to check both. So y has to be equal to 1 when x is 5, but is 1 less than 1? No, it's equal to, not less to. So even though it works for one, it has to work for both. And that's why you're looking at the shaded area for both of them, not the shaded area for each one. Okay, so once again, stay away from dotted lines is going to be the biggest takeaway. All right, example 2. All right, again, you're just copying it right into Desmos as you see it. So y is greater than 2x minus 8. And then on the next line, y is less than negative 5x plus 4. All right, and again, with our notes says copy post, then click on the second color line. And I don't like this black one. So what you do if you don't like the color, you're going to copy it, all right, onto the next one. So y is less than negative 5x plus 4. You see how it changes the color? So if you don't like the color, you can just do that. All right, so I didn't like the black one, so I changed the color. All right, so click the second one on the left to hide the second one. So there's the first one. We're going to copy the first one in first, okay? Pay attention to whether the line is dotted or solid. All right, so we need to transfer this line over to this side. We've already agreed in previous videos that making it a table is by far the fastest way, but it will not make a table unless it's an equal sign. So if you don't remember that, you're going to have to go get the coordinates. Let's see if these are some nice ones. Is that a nice one? Yes, it is. Is this a nice one? Yes, it is. If it's nice, just click on it. And by nice, I mean a whole number, no decimals. Okay, so I'm just going to plot that since it's nice. 0, x, and then y. 0, negative 8. And please, can you just double check to make sure, is it on the bottom? Is it close to negative 10? Yeah, that's what it is. And this one should be on the right of 0 to 4. Okay, so you're just double checking to make sure that you're putting your points in the correct spot, because I'd hate to get it wrong when you have it right in the calculator. All right, so it's a dotted line. Okay, so make sure you're paying attention if the line is solid. It's shaded where? On the top side of it. So go ahead and shade it on the top side. And you want to put a lot of lines because you want to be able to see the intersection really clearly. And then you're going to take a different color, like a pen on the first one, pencil on the second. And we're going to hide. So it says click the first colored circle on the left to hide the first one and unclick the second. So we're going to hide that one, unclick the second. Now we're going to copy it. Please make sure that it looks like it's going down and that's shaded the left and it's dotted. Okay, we're just copying what it is. All right, so we're going to see if these are nice numbers. I'm just going to hide this real quick. We're going to see if these are nice numbers. Now, we're running into a problem. That's not a nice number. Do not estimate it on your graph. That will be wrong. It does have one nice number, so I can go plot that one. All right, x is 0, y is 4. Well, different color, Miss Ainley. Come on, you just said it. All right, boom. But I cannot plot this one, which means I need to find the coordinate. So we've talked about 3 methods of finding the coordinate. I'm going to talk about 2 really quickly. All right, first one is we can make this into, as long as it's y equals, because it looks like it's y, it's going to be y equals. I don't have to solve an equation. I can write y equals and then just click a table. So I can just change the inequality to an equal sign. And then now here I have the table, and you can see 0, 4 is on the table. Another point is 1, negative 1, 2, negative 6. However, sometimes it's in standard form, which means you have the negative 5x goes to the other side, and it's not that simple. The other method that I want you to think of is you zoom in so that it goes up by 1, and you're looking by the corners. So you go to the box that's 1, 1. So you know this is the box that you need to be looking at, this big box, not these individual small ones, okay? So these big boxes. So you're looking for, is there a corner on those big boxes? So I drag my mouse there, and it looks like this is a corner right here. So I bring my mouse there, and I try to see if I move it along there, if I get really close to the line, bam, does it give me a whole number? It does. So that whole number is 1, negative 1, 1, negative 1. All right, 1x, 1, negative 1. I'm going to keep doing it just to kind of give you a little bit more practice. Okay, so you can see it pretty quickly if you can keep these boxes in your mind. So here's a box. Here's a box. It's not going through corners. Here's a box. All right, just keep going. And it looks like we just found another one. Here's a box. Boom, that looks like it's a corner. We're just going to double check, and it is 2, negative 6. So 2, negative 6. So again, you don't need more than 2 lines. This needs to be dotted. So please make this dotted. Okay. All right. So that's a dotted line, and you're shading which side? The left side of it. So make sure you shade the correct side. This is the left side. Wherever you're intersecting with the blue lines, as you can see, I'm already intersecting with the blue lines. Those are your solutions. But you can see, and this little part here in the bottom, you're not intersecting with the blue lines, right? So anything in here, stay away from what? Dotted lines. All right. So let's talk about solutions. All right. So copy the question down. Let's do it somewhere. We can just do it right here. Let's see, let's pick 0, 4, a solution. All right, and you always want to be able to tell me why. Is 0, 4 a solution? So I'm going to go to 0, 4, and you can do it, of course. You can do it from here. And actually, I forgot to mention, double check your graph to make sure it's correct. All right, double check your graph. I'm just going to zoom out for a little bit, and I'm going to hide one. So the blue one for me is up there, and then the red one for me is on the left. Okay, so yes, it looks right. Looks like they overlap right here, which is what mine overlap. So I just double check my answer. All right, so is 0, 4 a solution? So as a matter of fact, yes, use Desmos. Is 0, 4 a solution? All right, it's labeled it for me. It put the dot for me, so I don't even have to use my X and Y knowledge. All right, it is on a what? A dotted line. So is that a solution? No, it cannot be a solution. No, it is not. Okay, so I'm looking for anything inside here. Stay away from what? My dotted lines. Okay. All right, let me do one more example, and then you can do the last one. All right, so example 3, we're copying everything in just as you see it. Negative 5x plus y is less than or equal to 5. Next line, negative 6x minus 4y is greater than negative 24. Okay, boom. All right, I've got my 2, hide 1. So there's my 1. Let me see if these are nice points. Yes and yes. So I can just use those. I don't have to go get a box. 0, 5 and negative 1, 0. Boom. Is it solid or dotted? It is solid. So I'm just copying it down. Which side am I shading? This side. So we're going to shade that side on our piece of paper or on our Delta Math or on whatever program we're using. That's what we're going to shade. Boom. First one. Hide the first one. Open the second one. Let's copy that one down. Well, let's take a look. Is it good numbers? 0, 6. That's a good number. Yes, we got lucky. Good numbers. We don't have to look for the boxes. Change your color. So if you are using a pencil, use a pen, for example. All right, so 0, then 6. So right here. And 4, then 0, then right here. And you're asking yourself, open or close? It's open, so dotted. You're asking yourself, does your graph look like what is in the picture? Yeah, it looks like it's above the x-axis, then it's on the right of the y-axis. Yes, it does. All right, which side am I shading? The left. So let's go ahead and shade the left. It doesn't intersect here, right? You can see it does not touch the green. Now I'm starting to touch the green. I'm starting to touch the green. So that is my solution area. Okay, that is my solution area. So I put it back on. Okay, make sure it's shaded correctly. So I can see that my intersection is right here, which is right here. All right, so you know I'm going to ask you, is it a solution? Okay, let me try and trick you. Is, let's say, 0, 5 a solution. And you're going to tell me why. Is 0, 5 a solution? All right, so let's take a look at it. So I'm going to pick a different color. Oh, actually, I'm sorry. I forgot we're doing it in decimals. Is 0, 5 a solution? So 0, comma 5. Is that a solution? So there's my dot right there. Is that a solution? Is it in the shaded solid area? Yes, it is, because it's on just this solid line 0, 5, right? And it's included because it's included. Now, the question I have for you, so this one is yes. Yes. All right. And here's the trick question is, let's take this one out. This is a solution right here. Lord, this is a bad number, but it's okay. I just want to make a point. 0.154, comma 5769, a solution. Okay. So basically, is this a solution here? And the answer is no. Why? Because remember, it has to be a solution for both lines. And right now, the only place that's solid is this line. So it's going to work for this line, but it's not going to work for this line. You stay away from dotted lines. So this one is a no. All right, so you're going to do this next question. And the question I'm going to ask you is, go ahead and copy this down. Is 0, 0 a solution? And you're going to tell me why. Okay, so is 0, 0 a solution? Why? Okay, whatever your answer is, why? All right, perfect. So the only last thing I need us to do is just go over solving systems of equations. You've done this before. The only difference between inequality and an equation, it's in the word right here, equation, equal, has an imaginary L right here. All right, equation has an equal sign, not an inequality. But the option is the same, okay? So what you're going to do is the same as systems of inequalities. That means you're going to copy all of it down. Type it all up. Equals 22. And then x plus 7y equals 0. All right, so you can see there's no shading, right? So the only difference between solving systems of equations and inequalities is there is no shading, and the solution is only where the two lines intersect. And why is this a solution, guys? Because they're both solid lines, right? So if I come right here, the shading does intersect. The black and the purple only intersects at this point right here because there's no other shading. So this one is 7, -1 is the solution. Now, if you had the same line, it would be infinitely many solutions. All right. If you had lines that didn't meet, it would be no solutions. So I am going to check your understanding on whether you understood what I just said. So let's go ahead and transfer the graph over. Again, hide one. And then let's see, is it good numbers? It's not good numbers. That one is a good number, but it's off the graph. So we got to find it. So zoom in till it goes up by ones. It goes up by ones there. Now you're looking for the box. So remember, this is the box I'm looking at where the numbers are right there. So I'm going to come to the graph and I can see one right here. So boom, 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 right there. You're going to use your mouse to confirm -1, -3. So -1, -3. There's a point right there. So this is the purple line. All right, there's a box right there. There's nothing in there. Here's a box right here. Something is in the corner there. So you're going to use your mouse to confirm. 3, -2. 3, -2. And it's a solid line. Okay, so 3, -2. So draw it as best as you can. All right, so that's the first line transferred. We're going to transfer the second line. So we're going to hide this one, show this one. And I already know that one of the points that it goes through, actually, while I'm here, is 7, -1. So I'm going to graph that. Change your color if you're using a pen, use a pencil. So 7, -1, and I drew that so crooked, so I'm going to draw this bigger. I'm going to fix my thing because it needs to go like that. Okay, boom. All right, so I know one of the points is right there, and I just need one more. Okay, so I'm going to hide my purple line because I'm looking for my black line. All right, and look, the line is going down. So make sure when you copy this down, that's what you see. Let's see if we got good numbers. Yep, I have one at 0, 0. So 0, 0, boom, and it's solid. Okay, so using a solid line. Draw it as best as you can with a straight edge. All right, so this solution, so systems of linear equations, the solution is going to be 7, -1. So again, the difference between systems of equations and systems of linear inequalities, as you can see, there's no shading in systems at all. There's only one solution, or infinitely many solutions if it's the same line, or no solutions if the lines never intersect. So the intersection is the solutions. But you have to be careful with inequalities because this is the only place the black and the red meet. It's a shade, even though there's no additional shading. It's where the black and the red line meet, shaded, right? But when you come here and one is open, one is closed, even though they meet right here, it's not a solution because you got to stay away from the dotted lines. So where the green, in this case, green and red meet is going to be everywhere in here and solid, okay? In this example, where the red and blue meet, but again, I can't come right here because these are dotted lines. I got to go to just the shading. So I got to be anywhere in here. All right, so that's the difference between solving systems of equations and solving systems of linear inequalities. Let's practice.